All right, let's take a look at the most missed problems from today's assignment. The first one is number 20. It says a particle moves on the x-axis so that the graph of its velocity at any time is given above. All right, so we have a graph of v of t, all right, and that's our velocity. All right, and this says for what values of t is the acceleration of the particle increasing? All right, so we know that v prime of t would be the acceleration. All right, so if we want to find out if that's increasing, we need its derivative, v double prime of t, to be greater than 0. All right, now that means this graph, sorry, my computer's been a little laggy there. All right, this graph would need to be concave up for the second derivative of this graph to be positive. All right, it's concave up through this section here. All right, so we're looking at 0 to 2. All right, so 0 to 2, the derivative of this graph, which is acceleration, would be increasing because the second derivative of this graph is positive. All right, so that's 20. Moving on to the next one is 21. All right, this was one we went over in our session today. So really it boiled down to a substitution. We're going to take that and drop it into that function. And it asks for a third degree Taylor polynomial, so I'm only going to worry about up to second degree because when I take the antiderivative, it's going to take it up into the third degree. So I really have integral from 1 to x of 5 minus 2 times x minus 1 plus 3 times x minus 1 squared dx. All right, so if I take that antiderivative, I've got 5x minus the 2 and the divide by 2 would cancel, so I'm left with an x minus 1 to the second. All right, and then we've got plus, raise the exponent and divide, so the 3's cancel. I'm left with x minus 1 to the third. All right, and we're going to evaluate that from 1 to x. So I plug x in, I get 5x minus quantity x minus 1 squared plus x minus 1 cubed. All right, then I plug in 1, and when I plug in 1, I get 5 minus 0 plus 0. All right, so I've got 5x, and I'm going to bring this 5 over, so minus 5 minus x minus 1 squared plus x minus 1 to the third. All right, and I'm going to actually factor that 5 out so that everything has that consistent structure of the x minus 1 in it. All right, and we end up there. Now, when I look for that choice around, that choice is E. All right, and so I'll circle E and mark that one, and that is the second question that you had there. All right, so most common mistake on this one is to forget to deal with the fact that we had to plug the 1 in on that antiderivative. We can't just make it disappear like we do when we take the derivative because we're not taking the derivative on this. All right, going to 22. 22 says the graph of a piecewise linear function f is shown above. G of x equals the integral from 0 to x of f of t dt, which of the following is the expression for the line tangent to the graph at x equals 3. So I need g of 3, because that will give me the point, and I need g prime of 3, all right, because that will give me the slope. So g of 3, I'm going 0 to 3 of f of t dt. All right, so from 0 out to 3, that's this area out to the peak of that triangle. All right, so if I get a different colored pen here real quick, I've got in this section, it's down 2, it's over 1, so that has an area of 2. All right, the next section is over 1 and down 2, so that has an area of 1 for that triangle. All right, and then I go to the next one, that's over 1 up 4, so that has an area of 2. All right, so when I evaluate that integral, it's negative 2 minus 1, that's negative 3, plus 2 is a negative 1. All right, so that's the integral. Then it says the derivative. So the derivative of the integral, we really just get f of x back, so we're really looking for f of 3. All right, if I go over to 3, I end up at 4. All right, so that's 4. So now I want to write the equation of the tangent line. So I've got y minus y1, so y plus 1, equals slope, which is 4, times x minus x1, which was 3. All right, so y equals 4x minus 12, minus 1 more, so minus 13, and that would be A. Alright, so A is the correct answer on this one. Alright, going on to the next one that you had questions on, that would be 25. So 25 is a limit, so limits we always initially start with the direct substitution. And if I plug 0 in, I end up in the top, I've got limit as x goes to 0 of integral from e to e plus x of ln of t cubed dt. Alright, that would go to 0 because it's going to be the limit from e to e, and the limit where there's no width in the interval has to be 0. If I look at the bottom, I've got limit as x goes to 0 of just x, which is also 0, so it's indeterminate. Alright, 0 over 0. So by L'Hopital's, alright, we get the limit as x goes to 0. I take the derivative of the top, and the derivative of the top is a fundamental theorem of calculus. So I get ln of the quantity e plus x, right, to the third, times the derivative of e plus x, which is actually just a 1, right, over derivative of x, which is 1. So I plug 0 in, and I get ln of e to the third over 1. Alright, so ln of e to the third really says e to the what equals e to the third. The answer to that is 3, so I have 3 over 1. So this equals 3. Alright, so correct answer on this one is 3. Alright, moving on to the next one that you have a question on. It was 27. 27 I think was one of the toughest ones in here. When I look at 27, it's almost easier to start from the answers and go forward. Alright, so I'm going to start with this first one, and I'm going to think of it as a Riemann sum. Alright, so I'm going to have n rectangles, so I know my width, so my delta x is 1 over n. Alright, so as I move over from the start point, 0, so my inputs, so I'm just going to call it input, to get the right hand side's height is going to be 0 plus 1 over n times k. Alright, where k is basically the counter as I go from left to right across the region. Alright, so if I want to look at the area here, I've got 1 width times the counter, which I'll rewrite as k over n, squared, right, because the function is quantity squared, right, and I sum that up from k equals 1 to n. Alright, if I actually do that, that becomes, plug a 1 in, so 1 squared over n cubed, plus plug a 2 in, 2 squared over n cubed, plus 3 squared over n cubed, and so on, which actually matches perfectly to the top. So our correct answer is A. Alright, now if that didn't work out, then we would have had to go and do the same process for each of these until we got to the right answer, which can be a little tedious. The other option would be looking at the beginning and noticing, hey, I can factor out a 1 over n, and then I'm at 1 over n quantity squared plus 2 over n quantity squared plus dot dot dot, plus n over n quantity squared, and work from that to get that it's the first choice. But again, I almost think it's easier to look from the function, from the integral, and actually work your way backwards. Alright, so that's 27. And I believe that was all the questions. 28, the speed, we did not talk about that, so don't worry about 28 in terms of that part. You should be able to get to a position of 6 if you work through it, but the speed is something that's really left for a different class. Alright, so hope that answered all your questions. Have a great night.